So good evening my dear students and my dear friends. Today we will be talking about the last topic of your what we call as biomolecules. That's where we talk about the preservatives and action of soaps and detergents. So this when I talk about this is a little bit general everyday life in chemistry. That's where we talk about apart from your drugs which we talk about, especially the different kinds of the drugs which is available in the market. So that is where related to that, and we will be talking about the food adulteration part in this. Okay, before getting into the actual topic today, so let us look into the last class what we had done. So there we discussed the what we call as the commercial important polymers. I discussed about so many important polymers, Kelvar, okay. So we discussed about nylon 666 polycarbonate, then we discussed about polyamides, okay, Decron, so many polymers we discussed with their properties and their applications, okay. So after my class in the last session I gave a CPP. I think majority of the students who went wrong with this part, okay. So where we are talking about this was the question which was went wrong with the majority of the students when we look at that's where the polymer used in the bulletproof glass, okay. This is what the question which I given, okay. Good evening Mansi, Sunil, Josna, one and all who are there, okay. Now this was the last CPP question which were discussed. That is what the polymer used in the bulletproof glass. I think majority of you people went wrong with the Kelvar. I think because you know that Kelvar is basically used as not as a bulletproof glass, it is as a bulletproof jacket, okay. I think you answered that as a major, okay. And coming to the polymethyl methacrylate, I said because of its high transparent, okay, and opaque to UV light, and as well as much scratch resistant material, and it is highly transparent. So hence it is used in dentistries, not in any of these things. The Lemax, okay, which is the material which is used as what we call as the bulletproof glass, okay. What is that they actually they do is, this is the material which is sandwiched between the two glasses, okay. So the Nomex is another type of a material where which also finds as a glassy material, but it is not called as the bulletproof glass, okay. So I think all of you got the answer. The Lemex, okay, Lexon is called as what we call as the bulletproof glass. So then today's, let us look at today's the goals for the day. So we will be talking about the preservatives, okay. I think all of you know that the people who fond of the what we call as packed food or processed food which we talk about, how actually the food will stay about 3 months or 6 months or maybe 1 week, depending upon the what type of food you are talking about, whether it is a dairy product or it is a normal food material, okay. So or it is a protein, how we are going to store them. So what are the chemicals which we add, because the moment you think that whenever we are adding a chemical, definitely these chemicals will have its own effect on the biological system, okay. So that's why we look at which chemicals which we add and what is their role in their respective actions is concerned. The next is we talk about the introduction of cleansing agents, okay. Then we discussed in that the types of soaps, okay. Then advantages and disadvantages of soaps. Then what is the reason we have to look for the detergents, okay. So then what are the natural detergents or synthetic detergents which we talk about, and what is their composition, how actually they work in hard water. Especially the detergent came into existence only the soap could not work better efficient or the cleansing agent in the case of hard water. Thereby what happens, the new methodology of synthetic detergent comes into existence, okay. Then we talk about what is the advantages of soaps or detergent and the cleansing action of the soaps with respect to detergents, how they best do in their process, okay. So coming to the first and foremost is the chemicals in food I am talking about. That is where we talk about the first is sweetening agents. I think all of you know that. What is this sweetening agents? So there are many chemicals especially, okay, are added to the food for their preservation and their enhancing their appeal in terms of taste, in terms of look. So that's what we have to look at whenever we go for the hotels. There how we look for the taste as well as the garnishing of the food, how they serve, and what is the methodology of preparation which we look at, okay. So here also we do the same thing over here. So that's why there are so many additives will be added. We are not going to talk about all the additives because it is not required, and so I am talking about a few things that is called as the sweetening agents, okay. These are the agents, I think all of you know that these are the chemical compounds which give sweetening effect to the food to enhance its odor as well as the flavor. Such compounds are called as the sweetening agents. So when you look at the sweetening agents, I think all of you heard of the one of the best thing sweetening agent is the saccharin. Okay, when I look into this is also called as orthosulfobenzenamide. Okay, so this is the chemical name. So when you look at the sweetness of this is 500 times sweeter than your normal sucrose. I think we know that sucrose is called as the sweetest sugar, as also your fructose is also a very good sweetest. Okay. So then we talk about what we call as cyclamates, which is another form of your food preservatives. Okay, so which is cyclamates is a sugar once again as substitute, which is once again very much that means around 600 to 700 times sweeter than your sucrose. Okay. So then one and now it is banned because of its side effects, which we know that even though we use this in small quantities, they causes a lot of diseases, especially the cause of cancer was identified by the cyclamates. Hence this compound has been completely removed. The next another compound is what we called as aspartame. Okay, which is 160 times sweeter than your sugar. Okay, especially what we call as sucrose is taken as a standard. Okay, so the next if we talk about another, this sucralose, which is 600 times sweeter than sucrose. This is called as a trichloro derivative of your sucrose. Okay, and which is does not stable at cooking temperature. That's the reason it is not much used, because it decomposes. So then if we talk about so many other compounds are used, especially altamine, okay, which is 2000 times sweeter than sugar, used in the commercial preparations, especially it is difficult to control its sweetness because it's very high potency. So that's why this is once again a very much used component in the food water industry. The next one which we talk about is what we call as the preservatives, especially the food preservatives. So these are the chemical substances which are added to the food material to prevent their spoilage. That is what the food preservatives process. They are added to prevent the spoilage and retain their nutritivity value as long for a long period of time. Not long period, everything we cannot keep it for a long period. It depends upon the material or what kind of food we are going to store and what kind of the preservative we are adding. Based on that, the long period can be defined. Okay. So coming to, there are two types of preservatives. One is called as the natural preservative and another called as a synthetic one. The natural preservative, I think all of you know that, which is a very simple component which we use as sodium chloride. Okay, that's what the majority of the pickles which we prepare, it is added with the sodium chloride. Okay, so that acts as a preservative and it also makes a different taste for the pickle. That is where one way think of. And other thing is the good old days, we know that the sugar itself, the sugar syrup, especially when we talk about that syrup itself acts as the preservative. Okay, that is one best example of natural preservative. Coming to the synthetic preservative, we have n number of compounds like sodium benzoate. Okay, salt of benzoic acid, it is used as a preservative for fruits, especially the jams which you find in the market. They are all added with sodium benzoate, or potassium metabisulfite or sodium metabisulfate is used for the storage of the fruit juices, especially, okay, which is in the liquid form. So these are all the things. Then excess, if I talk about the fried fruits, especially the chips material which we talk about, the oil fried one, so those are especially stored in presence of what we call as nitrogen atmosphere. So that's where once again when we talk about the nitrogen plays a very important role in storing of the fried foods. Okay, and apart from that, potassium nitrate especially is added in storage of the meat. Okay, that is called as animal fat or protein. If you want to store, the potassium nitrate will be added here. That especially we talk about nitrate salts are added to them. So that acts as a better preservative because the nitrate molecule itself absorbs oxygen and prevents the oxidation of your what we call as the fat or the proteins. Okay, so these are all finds. And next topic of chemicals in the food is the antioxidants. I think this plays a very important role because the antioxidants are definitely, when we talk about their isoprene units, okay, of flavonoids. So that is very, very important. When you look at these components, so they have highly unsaturated alternate trans bonds. Apart from that, the keto groups will be present, so they act as good antioxidants. That is called as scavenging action of the free radicals which are generated in the biological system will be taken care by these antioxidants. So these antioxidants definitely they present in the colorful fruits, especially the fruits which are having colorful papaya, okay, when we talk about the beetroot. So the colorful, they contain much of the flavonoids. They play a very important role. These are the chemical substances which prevents the oxidation and subsequent spoil of the food. So that's why these antioxidants are added to the thing. So example, if I'm talking about the vitamin E is one such example, okay. So which acts as a preservative, or butylated hydroxyanisole, okay. This is once again a very important component which is added for food as an antioxidant. Next, when we talk about other components of food, edible colors as well as the flavors, we can find n number of components, quinine yellow, tarxinin, okay, sunset yellow, FC, and these are all when we are adding into the food for getting the coloration or as well as the nutritional value. I don't find nutritional value from these components, but they have to be used in small quantity, and these should be accepted from what we call as Food Drug Authority. So then only any of these chemicals should be added into the food. Otherwise, that chemical if we found in the food, then that is called as adulteration. That means the food quality is spoiled. So that's why, so when you are adding any of these food ingredients or the chemical substance to the food, it should be accepted from the Food and Drug Authority. So that's why the chemicals, what are the things which are adding, even though there is a minute quantities, they have their own role in biological system when it goes for metabolites. So that may causes lot of diseases. Okay. So with this we come to the next type of what we called as the types of soaps. When we talk about the types of soaps, I think all of you know that there are two types of soaps. One is hard soap and another is what we call as the soft soap. The hard soap is basically called as, okay, the hard soap, okay, which is basically obtained from KOH. So whenever an oil or a fat, okay, it undergoes saponification. I think all of you know that saponification is a process when oil or a fat is treated with an alkali, okay. So that gives a sodium salt, then it is called as soft soap. If it is the potassium hydroxide is used, then it is becomes hard soap. So that's why the saponification process, if I use this KOH with the salt which I am getting with the stearates, okay, that is called as hard. And the soft soap if we call as, okay, so this is the sodium hydroxide is used over here in this process of saponification. So that's why we get two types of soap. So this is also called as the toiletry soaps, and other is called as the washing soaps, especially the hard soaps which you are talking about. Okay. So soft soaps are basically made with the vegetable oils especially, okay, and when we talk about the esters of glycerol and fatty acids, okay, which are the byproduct of this, glycerol is removed, okay, by using salting out process of the what we call as soap manufacturing steps. The next is how actually these soaps works. Okay, so now when you're talking about this, there are, once again I am talking about the laundry soaps, how it works. It is a different mechanism, and the toiletry soap is different mechanism, and the hand washes which we use, the liquid soaps, they are having different mechanism. Now look at the main characteristics of these things. It made from a cheap oil. That's why the laundry soaps are washing soaps which is very hard in nature. So then what we called as the toiletry soaps as made from a good oils. That's why if you look at the different soaps which are available in the market, they vary with the cost. Okay, I don't want to name any of these things because we are not into the marketing. That's the reason. So I am telling about, you know that market soaps are different. So each soaps, when you look at buy the soap, and if you look at the composition of that, so you can find different composition, as the quality of the oils which are used in the manufacturing of that particular soap always gets into high costlier. Okay, so that's why, so the export soaps which you talk about are the soaps which comes from especially the Mysore sandal we talk about, the oil which we are using, definitely the cost of the soap goes up, okay, because it has to be taken from a sandalwood. The process itself is costly. Thereby, the cost of the soap purely depends upon the oil which they use for obtaining such. The next next topic, that is the liquid soaps made from especially oils like coconut, caustic soda, and the water. Okay, they can be used as shampoos and floor cleaning agents. So coming to the floating soaps, these are made by beating the large quantity of air into the soap. Okay, and these are especially when we talk about shaving creams, they are made with that. And medicated soaps, especially the carbolic soaps, I don't want to name once again. So these are all the components which are present in that neem oil, okay, Dettol, okay, these are the things which are specifically used for certain skin diseases. So that's where we call it as a medicated soaps. And next is the transparent soaps. These are especially comes under the category of bathing soaps, okay, and shaving soaps comes under the once again same category of this, but there also we find N number. As the value of the content, what we called as the glycerin increases, the softness of the soap also increases. So that gives a smooth feel to the skin. So that's where the transparent soaps comes into the picture. Then is the metallic soap, okay, especially these are obtained from metallic salts like lead and aluminum, okay, other than sodium and potassium. So these are basically used as a dryer for the paint and waterproofing textile industry. So that's why this metallic soap goes when you are manufacturing a kind of what we call as a jeans material. So there after dyeing, so they want to make this color to fix onto this. So that time, so they use these kind of soaps in order to fix the dye to the fabric. Okay, next coming to the advantages of your what we called as the and limitations of soaps, there will be a lot things which we can talk about. The advantages is when we talk about good cleansing agents. So that's what the soap thinks, and they do not cause any pollution problem. That's what we used to say earlier, but nowadays we don't say that, because even the chemicals which we are using, even though it enters in a small quantity also, that causes a lot of water pollution from the household or domestic waste. So that's the reason we don't say it is not going to cause, because of the huge market demand, the quality of the chemicals which they use in the what we call as a soap manufacturing, it may not be of good quality. That's the reason it will definitely damage the water which after bathing, because any household does not have a effluent treatment plant or the what we call as the chemical treatment plant in the each house. Thereby what they do, they will allow it as a sewage, and that sewage definitely gets contaminated. Thereby I cannot use the word it is not going to contaminate. Next, coming to the limitations of the soap. So what it talks about, soaps cannot be used in water, hard water especially. That's where it causes a scum kind of material. It is not going to give free lather. Thereby the cleansing action is not supported much with soap in case of hard water. And the soaps cannot be used in acidic medium because the dissolution is not going to occur easily. That's the reason even the saponification process also, if we look at, it is not done by using hydrolysis, acid hydrolysis, it is done by basic hydrolysis. So thereby we cannot use them in the case of what we call as acidic medium, or the water is acidic, we cannot use this salt. Next, to overcome all these problems, there is a next kind of material came into existence. That's where the synthetic detergents. Detergents are non-soapy cleansing agent that uses a surface active agent, okay, for a cleaning of a substance, okay, in a solution form. So that substances are called as the synthetic detergent. That is also called as soapless soaps. Okay, so that is where we talk about. So when we talk about a modern synthetic detergents are sodium salts of long chain fatty acids, okay, or sulfonic acids of sodium salts. When we talk about this, there are two types of things. I think we can look into that. The structure goes like this. So this is especially we call it as sodium daquil sulfate or sodium lauryl sulfate. These are basically contains a huge chain of what we call as long chain. So one end will have a polar group, okay, sulfonate with this thing, and another end will have C12 H25. When you look at this structure, it looks very huge. That is what we call as sodium paradodecyl benzene sulfonate. Okay, so this is a very important component which is present basically in all kind of detergent. Why the shampoos will give more froth is because of these kind of components: sodium lauryl sulfate, sodium daquil sulfate. These components make them to work in hard water also. And the next is the sodium lauryl sulfate, which I am talking about. Okay, so this is a sodium lauryl sulfate, SLS, which is called as very simple way. Okay. So now this contains two groups. One is, you look at here, there is a SO3 with a negative charge and there is a positive charge on sodium. So this makes the dissolution of what we call as this component into this, and the oil or a grease which is stuck to the fabric can be easily removed by using a non-polar end over there. Whereas if you look at your normal salt, okay, normal soaps, where we are having C12H25, okay, Na plus. Okay, this we have only one charge on this. That's the reason the soft soaps or hard soaps which we are obtaining only from oil cannot work in a better way in hard water. Here in this case we have two charges, negative as well as positive. So thereby it makes dissolution of this component easily with respect to the oils and grease which are on the skin, or it may be on the clothing material. The next is the composition of the common detergent. If you look at, that's where the composition goes like this: the sodium alkyl benzene sulfonate, that's what the molecule which I shown over, it contains about 18%. Then the de-dusting agent will be about 3%, the foam booster is about 3%, and sodium tripolyphosphate, okay, which acts as a builder, which is about 50%. That means the maximum is a non-useful component, which is a booster, okay, sodium triphosphate. Okay. Radhika is asking sir, sodium acetate and sodium benzoate, are they both food preservative? Yes, sodium acetate as well as sodium benzoate can be used as a food preservatives. Definitely, there is no problem. So majority of the liquid foods which you are preservating today in the market, which are comes, all are added with the sodium benzoate, 99.9%, and sodium acetate we use less because it is a good chelating agent. That's the reason that if it is consumed more, it can come in contact with the bones and it can remove the calcium easily. So that's the reason the sodium acetate is a chelating agent. We are not using that much, but sodium benzoate you can find in larger quantities in any liquid foods, okay, liquid food as a preservatives. I hope you got. Next is anti-corrosive agents. So this is added for the what we call as a fabric material which we use. The skin should not get rough. That's the reason anti-corrosive agent will be added when we handle these detergent as well as the soaps. Next, optical brightness, because after drying the cloth, because you should have some brightness. That's where we use what we call as the free lone pair present atoms, especially the sulfones, which will be added into that. That is added in a small quantities. Next, water and inorganic fillers will be about 19.7%. So these are all basically added to maintain the composition. The important thing is the first three is very, very important. Okay, so that makes them, even though we use a small quantity of this, but these compounds, once they come out of washing agents, okay, so they are very, very dangerous. That's the reason the sodium sulfonate, which you are finding out here. So you might have heard of in the newspapers, whenever the sewage comes over there and it catches the fire, because of this the sodium definitely accumulates, and apart from that this sulfonate, which is once again a firing agent, that makes whenever it goes with the what we call as oxidation process, it get into more of froth formation, and apart from this sulfonate as well as the sodium, they are highly reactive in nature when it comes in contact with oxygen. So that's the reason it makes the fire on the lakes nowadays. You might have heard in the newspaper, because all the sewage we directly enter into the lakes and there is no purification which is done by the respective bodies. So coming to the synthetic detergent, where we find three types. One is called as anionic detergent, and next one is called as the cationic detergent, and next is called as non-ionic detergent. Okay, there are three different types of synthetic detergents, as the name itself talks about what they are. Okay, so that's why we call as the anionic, cation, and non-ionic. Okay, so these are the sodium salts. Okay, whenever we talk about anionic detergents, these are all called as the salts of sodium or sulfonated long chain alcohols or hydrocarbons. So in this we have two types. One, the first type I am going to talk about is called as alkyl hydrogen sulfates. Okay, so when you look at this, as I already said, I am not going to write the complete molecular formula, just I will write lauryl hydrogen sulfate. Okay, this is called as not mathematics I am talking about, this is called as lauryl hydrogen sulfate. So if you want the molecular formula, it goes like this: C11H23, okay, then it goes CH2OSO3H. Now if you observe carefully, this is what we called as non-polar chain, and we have minus and as well as plus chain on the sulfonic acid group. Okay, so then when it is treated with the NaOH, that is called as basic hydrolysis. So with the elimination of water, it's going to form C11H23 CH2SO2ONA. So very simple, the H plus goes with the OH minus, okay, then it forms, and this is the solution which you get. So that's what your alkyl hydrogen sulfate which is goes over. Okay. So now another examples if I want to give, that is called as sodium stearyl sulfate, which is also another component which is comes under alkyl hydrogen sulfate. I think some Renu is asking for the contest question. Yes, I am coming to that point only. After another 2 slides, I will be there with the previous contest winner announcement time as well as the contest question which you are waiting for that. Okay. So next is the anionic detergent. Then we talk about the cationic detergents. Okay. So these are basically ammonium salts of amines with the acetates and chlorides as well as the bromides containing one or more long chain alkyl groups. So that is where I will give one example for this, that is where CH3 CH2 16 times, then CH2N, okay, I am talking about amine salts, thereby you have to know the quatermonium salts will be there. So thereby CH3 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 and the Br. Okay, so this is the one of the what we called as a trimethyl stearyl ammonium bromide. This is one of the component which is used in your cationic detergent. Cationic detergents also have a germicidal properties. Okay, that is what once again, and thereby the cost of these detergents will go little higher end. Okay, the cost especially these can be found in what we call as air conditioner shampoos, these kind of components. The last part which I am talking about is non-ionic detergents. Okay, that is where when we talk about the stearic acid comes in contact with the polyethylene glycol, the resulting compounds which we talk about is called as non-ionic type, especially the dishwashers which we use at the house. So they should not be ionic or they should not be cationic, only that kind of things. That's why we call it as non-ionic nature, because majority of the dishwashers will contain organic matter, thereby only organic matter if it is present, it can dissolve the organic matter easily and effectively, thereby so we are going to make use of non-ionic detergents. Okay, so when we talk about this, they are these are the more biodegradable, as they are usually the straight chain with the less branches. That's where the application of non-ionic detergents. Coming to the differences between the soaps and detergents, I think majority of you know that the soaps are sodium salts of higher fatty acids, where the detergents are sodium salts of long chain benzene sulfonic acids. That is what the basic difference, you have to know that. Next is the soaps. Calcium and magnesium salts of soaps are insoluble in water, whereas the calcium and magnesium salts of detergents are soluble in water. That's why this makes them to work in even hard water also, where the TDS, the total dissolved solids in the water, if it is more, even these detergents work in a better and effective way. The soaps are prepared from the natural oils and fats. The synthetic detergents are prepared from the petroleum, the products which we get as the middle oil fraction after naphthalene, okay, benzene. These are the components which we obtain from the middle oil fraction. From there we can obtain this. The soaps cannot be used in acidic medium, whereas the detergent can be used because it contains both cationic as well as anionic. Based on that, it works in a better way. That's why it is an amphoteric part is concerned. Soaps are biodegradable. Okay, most of the detergents are non-biodegradable. Okay, coming to the previous question, I think Renu was waiting for this. Okay, the previous contest question goes like this: the formula of 3-carboxymethyl hexane 1,6-dianic acid. Okay, this was a question was asked. The answer goes with respect to C is the right answer, and the winner is Samarenika. Okay, I think Samarenika, you get 1 atom session to your account, and the congratulations once again. And I think you are all waiting for today's contest question. The contest question goes like this: which of the following chemical is added in washing powder for keeping it dry? Okay, which of the following chemical is added in washing powder for keeping it dry. The options are sodium silicate, inorganic phosphate, carboxymethyl cellulose, and sodium perborate. I think you're not started answering. Your time is up. You have to make it fast. I hope countdown starts now. 5, 4, 3, 2, 1 and 0. Okay, well, let us continue with today's topic. That's where I'm talking about advantage of detergent over soap. We can give n number of advantages. Okay, I think if you go on looking at the synthetic detergent can be used for washing even in hard water. That's what I was discussing and I was telling from last 10 minutes. And synthetic detergents can be used in even in acidic solution as they are not readily decomposed in acidic medium. That's what one thing which cannot be done in case of soaps. And synthetic detergents are more soluble in water than soaps. That's one advantage. And synthetic detergents have a stronger cleansing action than soap. Some synthetic detergents give foams even in ice cold water. That is what the beauty. So that's why we can find the pure natural extract of oils. So that's where we get that kind of special properties. Okay, so that's where things. Next is water repelling or water phobic part or non-polar part, which consists of a long chain hydrocarbon part and a non-volatile which is insoluble in water but soluble in oil and grease. So that makes the cleansing action in a better way for the detergents. So that's where we are talking about how actually the cleansing action of the soaps and detergent works out over here. Okay, so that's where when I talk about this part, you can look at the part of the molecule which is present here, that is in the case of soap and the detergents are purely different. So that's what if you look at the molecular structure which you can see here, there is a non-volatile which is called as hydrophobic nature, which is the water repelling agent, okay, or water eating component. Whereas if you look at the polar head where there is attraction towards the water takes place. Similarly, if you look at the same detergent, we have once again the long chain fatty acids, okay, along with that we are going to have an polar head which is having a more attractive, because the carbon which you use here, we are going to use below the carbon one more element is there which is the sulfur. Okay, so that's where we are talking about this is having more. Compared to carbon, the sulfur will go for extended valency because of availability of d block elements, d orbitals, especially when I talk about. When it comes to the carbon, because it's a second period element, it does not have that what we call as extendable valency. It can go for catenation with only the 4 valency, but the sulfur is having a special property of d orbital existence, and which makes a better attractive power because of more binding sites. That's why if you look at here, the oxygen which is present over here is just 3 atoms, whereas in the case of this we can find only 2. So that makes a special property for this. The cleansing action comes into picture. Now what will happen to this when these are added into the water? I think all of you know that there is a formation of micelles takes place. These micelles will start attracting towards your oil or a grease, which depends on the what kind of material you are going to remove and what kind of detergent or soaps you are using. Okay, so that's why, so how actually the process occurs or the mechanism of once the micelle formation takes place. This micelle formation also starts initially slowly, then it will reach a particular saturation state called as critical micelle concentration. Once that is CMC is reached, then automatically the soaps or the detergent will start acting on the oil or a grease, which may be on the dirt or on the cloth or on the skin. The first thing is the dirt and the cloth is due to the presence of dust particle, that is what fat or grease which is stick to the cloth. The second point, the micelles, these aggregates of soaps or detergent molecules that will get into CMC, then only they will start acting the next. Thus when soaps or detergent dissolved in water, the molecules got together to form a cluster of these long chain hydrocarbons along with the polar head and non-polar tail. Those are called as the micelles. Okay. Next, when the dirt of the cloth is dipped in the soap or detergent solution, the soap and the dirt particle come in contact with each other, where this micelle starts engulfing those dust particles or the grease. The non-polar tail particle or tails of the soap begins to dissolve the non-polar oil or the grease, while the polar head part remains directed in water. That's why there is a segregation of hydrophilic and hydrophobic end takes place. The further when this, okay, that means the more soap particles enter to the grease, each fat or oil particle surrounded by the number of negatively charged particle becomes the more and more, okay, and then they start interacting with what we call as the grease or oil, and the hydrophobic part will be completely interacting with the oil and grease, and hydrophilic will be on the other side of the what we call as polar end of water molecule. Next, this prevents the small globules from the coming together to form a bigger particles. That's why what we call as engulfing takes place. The small oil and grease which gets with the non-polar, and they start removing from the surface of the cloth. The next, the rubbing of hands or mechanical stirring also makes them to get into what we call as in a better way. That's why, so whenever they're cleaning the hand or what thing, we rub after adding a soap or what we call a detergent to your hand wash into your hand. So that makes a better cleansing action because of mechanical force which we are applying. So that makes the breaking of these larger oil drops or the grease into smaller globules, so that the effective action of the detergent will be done in a better way. Next is the grease particles can be completely broken up and like form emulsion. That's where a kind of material which is oil with another oil forms a substance which is emulsion of grease. Okay, then if you give a water wash, finally the grease or oil which was stuck onto the cloth or what we call as the skin comes out with the non-polar part of your soap or detergent. So this is what the cloth gets free from. Finally, the dirt and the droplets are washed away from with plenty of water. Okay, this is what we call as the cleansing action of the soap. So when we talk about the cleansing action, I think majority of you understood. It's very simple technique. What do you do? We add a detergent, dip the cloth, okay, allow for 5 to 10 minutes. That aging time is given for the reaction of the non-polar part of your detergent with the non-polar oil or a grease, so that when you shake 2 or 3 times the cloth or your hand, then automatically the larger grease particle breaks down, and then this non-polar part will engulf that particle, and when you give a water wash, immediately that particles will be out of the cloth, and then your cloth will get washed away with dirt. So this action and mechanism is called as cleansing action of the soaps or detergent. Okay. So before concluding this class, so let us look at what we have discussed today's. Okay. The introduction to the cleansing agents we discussed. Okay, we discussed about the types of soaps. We discussed the advantages or disadvantages of soaps, synthetic detergents and their composition, differences between the soaps and detergent, and advantages of soaps over detergent, and the cleansing action of soaps and detergent. Apart from that, we discussed some of the preservatives which are added for your food. Okay. So now, so after my class, I think all of you know that there will be a CPP, that is where class practice session packs will be given to you. I think a majority of your students are passport users. I request all of you to log into that part and answer the questions. Then the non-passport users, I request to join to as a member of the passport user and make use of the facility of today's topic. Thank you for joining with us.